guide has to introduce the scholar. Guide has to introduce the external examiner. Then the guide will invite the external examiner for a few words. After that, the external examiner has to hand over the podium to candidate. You can start, madam.
Morning to everyone. It's an honor and privilege for me to welcome each and everyone. First of all, I would like to invite my gurus, Dr. G. Arumugam and Dr. M. Tangaraj, and our respected principal madam, Dr. S. Vanadi, Sri Meenakshi Government Arts College for Women, respected Dean and Head of the Computer Applications Department, Bharatiyar University. I extend my warm greetings to the distinguished external examiner, Professor Dr. M. Usha Rani, and I welcome the great personality, university nominee Dr. Satish Kumar sir. I am delighted to welcome the head, Dr. M. Sumati, Department of Computer Science, beloved head, Mrs. R. Rajarajeshwari, Department of Computer Applications, Sri Meenakshi Government Arts College, and I welcome all the faculty members of Sri Meenakshi Government Arts College and Bharatiyar University. And I'm pleased to welcome the research scholars and participants from various institutions for the viva hours of my research scholar, C. Ranjit Kumar, in the title, Three-Dimensional Video Retrieval from Visual Semantics under HDFS Environment. Related with his research work, he has published 2 papers in Scopus Indexed Journals, 2 papers in IEEE and Springer conferences, and published the core work titled Visual Semantic Based 3D Video Retrieval System using HDFS. In the SCI Indexed Journal, PC Transactions on Internet and Information Systems. Currently, he is involved in the process of capturing the live images from surveillance camera as the extended work of his research. I express my sincere gratitude to the university nominee, Dr. J. Satish Kumar, for his support and gentle guidance throughout this process, and extend the gratitude to the external examiner, Dr. M. Usharani, Professor, Department of Computer Science, Sri Padmavati Mahila Vishwa Vidyalayam, Tirupati, for their valuable support. I extend my heartfelt thanks to Melba Rosalie, T. Sudha, and Shivajyoti for their fullest cooperation in the conduct of this viva hours examinations. Let me share a few points about the external examiner, Dr. M. Usharani. She is having vast teaching and research experience. Her research area includes data mining, big data analytics, cloud computing, and artificial intelligence. She has published 6 books and 100+ journals and presented around 100 papers in national and international level conferences. She has organized many conferences and handled many funded projects. Under her guidance, 6 scholars completed their PhD, and currently 10 scholars are pursuing their PhD. She is an active member of NAC Advisory Committee, International Association of Engineers, IEEE, ACM, WACM, and CS. She had various administrative positions, including head of the department, nodal officer, and the director computer center. She has also received the Special Appreciation Award of NSS Bureau for the year 14 to 15. With these few words, once again, I welcome you all. I hand over the session to the external examiner. Ma'am, please take over this session.
Yes. Ranjit Kumar. Thank you, Suguna, for giving this opportunity.
Thank you.
Okay. Ranjit Kumar, C. Ranjit Kumar. Yes. Start your presentation. Where is he? Share the screen. Yes. Share the screen, Ranjit Kumar. Is it audible to me? No, it is not audible. Just you have switch off your microphone. Unmute the microphone, ma.
Yes, ma'am.
Yes. You can start the session.
Okay, ma'am.
Present your total thesis.
Shall we start, ma'am?
Yes. Okay. Share the screen. Share the screen and continue your presentation. Put it in the PPT slide mode, slideshow mode.
Can you see my screen?
Yeah, put that in the slideshow mode, Ranjit Kumar.
Yes, ma'am.
Yes. Okay. Now start with the session.
Good morning, everyone. First of all, I invite you all of them to this session. Myself, Sri Ranjit Kumar, part-time PhD scholar, Baldiar University. My special invite to my guide, Dr. A. Suguna ma'am, Assistant Professor, Sri Meenakshi College, Madurai, and my special invite to my external examiner, M. Usharani ma'am, Padmavati Mahila Viswavidyalaya University, Women's University, Tiruchirappalli, and my special invite to my university nominee, Dr. J. Sadish Kumar, sir. So once again, I welcome you all of them to this session. So now I move to my topic, three-dimensional video retrieval from visual semantic under STF environment. In my topic itself, I clearly mention two main objectives of the research. First one is with video retrieval and second one is STFS. These are the two important objectives of the entire research. Then the agenda of the session, first introduction, second content-based video retrieval process. It is one of the existing technique. After start the research work in the content-based video retrieval, we find some issues and problems. So we try to provide the solution for those problems. According to that, we start our proposed system. Based on that, we design the entire system. In our proposed system, we mainly focus on 6 features. First one is keyframe selection. Second one is feature extraction. Third one is backup visual words. Fourth, similarity matching. Fifth, ranking. And sixth, map reducer. These are the 6 major process in our research work. Later, I will explain one by one. Then our data set and contribution of the work and comparative study, conclusion, future work, list of publication, references. These are the entire session details. First, retrieval. Retrieval is one of the multimedia concept. Retrieval process is mainly used in search engines and social networks. The retrieval process is possible in all 4 data formats like text, image, video, audio, all kind of the 4 data formats. The retrieval process is possible. The process is mainly done in the search engine concept and social networks like Google and all kind of the social network concept. The retrieval process is normal available. The retrieval process is mainly, we need to consider 4 main issues. First one is relevance. The relevance in the sense the retrieving data, how related to the input and output. The relevance of the data is very important. And then retrieval data content quality. Quality of the content is very important. Low latency. The entire process time taken is very minimum. That is main objective. Then we need to avoid the duplicate of the retrieval data. These 4 major process in normal all kind of the retrieval process. So the retrieval process is mainly helpful to the search engine concept and social networks. So we are all know the search engine and the social network concept. Social networks growing rate in year by year. It's gradually increasing year by year the growing rate of the search engine and the social network. The last 5 months, we are all know the world economical situation due to the COVID-19 issue. Under the hostage situation itself, the search engine and the social network, the digital marketing, and the digital-based business sectors, uh, they increase the business levels only due to the hostage situation itself. Uh, so my strong belief, the image to video retrieval concept definitely we need to in future years. This concept definitely used to help for the real-time environment. So the retrieval process.
I request all the participants please mute your audio.
Madam, host can simply mute all. Host is having,
Yeah.
and then you check it whether the total program is recorded. Ranjit,
Yes, sir.
you
Sir, I can't hear your voice, sir. இல்ல மேம் நீங்க ஹோஸ்ட்ல இருந்து மொத்தமா மியூட் பண்ணனால சாரும் மீட்டுக்கு
okay, no issues. Ranjit, I'm unmuted.
Okay.
You take much time on your contributions. Okay.
Okay, sir.
Fine. Continue. It's nice. Continue.
So the retrieval, there are mainly 4 type of the retrieval process. First one is text to image retrieval. It is not normally available in all search engines and social networks. The Google is we are mainly focusing the text to image. First one is text to text retrieval. It is normally available in Google also. Normally we are using that type of retrieval techniques. And second one is text to image retrieval. That is also available in Google search engine. Then third one is text to video retrieval. That is available in the like YouTube, that kind of the online medium. It's available. The fourth one is image to video retrieval. That is our proposed system. The user going to provide the input in the image format. The corresponding output they get in the video format. That is our system, image to video retrieval. The image to video retrieval, normally the retrieval processing in majorly focus in the 2 type of the features. One is object based and another one is content based. In our system, we proposed both features. We using the both features, object and content based. Both features we are here using, so that we need to ensure the quality and performance, timing and accuracy, everything we can ensure. So we using the both features in our proposed system. These are the details. The image to video retrieval technique we are using in our work. There are 2 kind of the features, object based and content based. In object based, they classify in 3 major parts. First one is temporal. The sense object changes over a time, we consider the temporal feature. Then second one is spatial, position, angle, orientation based features called in spatial feature. And third one is motion in the sense the moving of the object. It's under the category of motion. These are the 3 main features in object based. And content based, the color, shape and texture. These are the 3 features for content based feature retrieval process. We are using content and object, both features we are using in our work. That is our survey details. Before start the work, we refer minimum 100 papers in all reputed benchmark reference journals. According to the reference, we find retrieval algorithms, retrieval processing techniques, data set details, everything we gathering through the literature survey. Here we list out some of the literature information here. And this is existing technique, CPVR, content-based video retrieval. In the existing, most of the papers, they discuss only the 2D data set only. No one discuss about the 3D for the image to video retrieval processing. So we find this is one of the issue in the existing system, because recent days, most of them using the 3D images, 3D videos. So it is one of the existing technique. And second, the existing researchers using any one of the feature like object or content, any one of the features only they are using. So in that case, we feel some typical shape and some typical structure and typical color formats. We can't easily understand. We can't get the semantic images. So we need to try to implement the both features. And third one is data collection. And in previous works, they discuss about the single normal system only. They are using the entire process. So in this case, we felt in the earlier stages of the research, the data processing speed and the storage of the data, it's not enough in the normal system. So we go for the map producing. Then third, noise. The image and the frames noise is very high in the existing system. We try to find out the solution for all the existing issues. This is our objective. In the retrieval processing, we go for the query based. We're using the top k nearest algorithm, and then we discuss image in map producing. Earlier in our in the beginning of the research, we using the normal system only. We all know the video processing technique normally take huge storage space, because the video directly we can't use the entire processing of the techniques. So first we need to split the videos into the number of frames. So if we cut the 1 minute video, definitely it comes nearly 2000 3000 frames. So normally the data processing storage capacity, it take too much compared to the text, the image and video. It take the huge data storage spaces. So the normal system is not sufficient for this kind of the process. The processing timing also, the normal system took very much. So we go for the map producing concept. For the purpose of storage and processing timing, we are considering the Hadoop for our proposed work. Then we are mainly concentrate the semantic meaning, semantic images. The base we try to retrieving by the help of the 4 features. This is our proposed system. In our proposed system, we find the solution for the symmetric retrieval, and here we consider only 3D data sets, 3D images and 3D videos only. Here we are using the entire work. Then we are focusing the content and object based retrieval techniques, and using the features we can retrieve the complex shape also. Then the large scale and high quality of the retrieval can possible. The unlimited database data storage is supported by the help of the Hadoop MapReduce concept. Then this is our overall architecture. In the architecture, we split in 2 parts. One is offline mode and another one is online mode. The offline mode, the data owners handling. The offline mode is common people, the common users who going to provide the input. They're using the online processing mode. First, the data owners upload the videos into the server. The videos we can't directly using our process, so we cut into the many number of frames. The single video we cut n number of the frames we cut, and we store the entire frames in our data storage. The user going to provide the input image. The input image is only 3D images only. Here going to we provide the input, and the corresponding input. First, the feature extraction is function is occurring. The feature extraction, we are using the triplet feature extraction, because we are using 3 features: shape, color, texture. So we call this function name is triplet. So after completing the triplet feature function, it's going for the visual backup words. And after completing the process, we collect the backup visual words. The backup visual words means it's in the pixel format. Finally, we get the result in the pixel format. The pixel format comparison only can possible in the already the storage server converted video frames. So both backup visual words are similar. The corresponding frame related video is going to display into the user. That is the entire overall architecture. So in our proposed system, we mainly concentrate 6 stages, 6 processing. First one is keyframe extraction, second feature extraction, third backup visual words, fourth similarity matching, fifth ranking, and the entire process is done through the Hadoop MapReduce system. So that is Hadoop MapReduce is our sixth process. Now I explain one of the process. First, keyframe extraction. The video is split into the n number of the frames. The m number of the frames. For example, if we cut a single minute video, we get minimum 3000 frames. N number of frames we can get it. Most of the frames are duplicate. Most of the frames are some noisy. So we need to filter the frames. We need to collect unique and best frames only. So here we are using the Gaussian filter function. Using the Gaussian filter function, we can get the only the rich frames and rich images only we can get it, because the Gaussian filter provide the reduced contrast, sharp, blur images, edges, removing noise. These kind of some issues, the Gaussian filter provide the solution. So finally, we get the rich semantic images only. The smooth and then we using the smooth and histogram technique. It is also using to get the quality frames only. So using the two functions, we work the entire keyframe extraction function. The keyframe extraction, there are two variations, temporal and keyframe. And the temporal variation, we can get it the number of frames, frame rate, order of the frame sequence. These are the informations we collect through the temporal variations. And using the keyframe, contrast, brightness, color intensity, resolution, these information we collect through the keyframe extraction. So these all the features is help to identify the best keyframes, exact value keyframes we can easily extract. And the existing technique, they are using the entropy difference, color histogram, image epitome, visual contents, camera motion. These are the features they are existing used. These features is normal image processing features only. So in our study, we find in these methods is not sufficient to identify the some complex, some difficult shapes and images. So we proposed in our system in keyframe based, and major issues we find it's affect to the relevant semantic information. The image and the frames semantic value definitely we missing in the existing system. Large noise is occurring and time consuming is huge. Very poor high quality images is not possible. This is the flow of the keyframe extraction. The keyframe extraction, normally we using the all image processing mathematical equations, mean value, deviation, computation, histogram value. These are all the image processing mathematical equations we are using to find the keyframe extraction. First, we calculate the first the keyframes, number of keyframes is available. All the frames we using the we calculate the mean and deviation values. Using the mean and deviation values, we provide the input for the smooth frame and the Gaussian filter, smooth frame technique and Gaussian filter, both functions we are using here. Using the both functions, we get the high enriched image quality only. So here we avoid the noise, duplicate, and some repeated images. Everything we avoid. We get the only keyframes only. We finally we getting. After the in processing, we calculate the histogram value for the selected frames, and the histogram value based only we consider in the further process. This is the pseudocode for the keyframe extraction. This is one of the sample for keyframe extraction. The user provide the someone sample input video. The input corresponding we get n number of the frames. The frame based we get the unique semantic value keyframes only. Finally, we get it. The second step is feature extraction. The feature extraction we using the four methods: shape, color, texture. These are the content-based features, and motion one is object-based features. And the earlier researchers they using any one of the feature, any one of the feature. It may be an object, otherwise content. But here we are using both object and content, both features we are using. So in further process, we consider all these four features: the shape, color, texture, motion. The four feature based only we can get the final extracted images, extracted frames. This is the pseudocode for the feature extraction technique. First one is shape. The shape feature normally is considered three segment: topological, geometrical, super ellipsoid appreciation. And the topological means the medial segmentation, readjustment of the segmentation is under the topological feature. Geometrical in the sense height and width, the height and width of the object we consider in the geometrical feature. The meaningful parts we can identify using the geometrical feature. Super ellipsoid means finally we need to represent the graphical parameter, the graphical input. That's in that sense, the pixel value only we can provide the next stage, next process input. So finally we get the graphical result. So this is the feature extraction steps. First, the user provide the 3D image. 3D image directly we can't process. So here we are using the shape function. First step, we using the topological function. Using the topological, first we identify the outline of the particular images. The boundary of the image only we consider in the next step. Then the boundary based the overall structure we draw using the geometrical, and the object height and width based we are using the geometrical function. By the help of the geometric function, we readjust the segmentation. We draw the entire picture. The entire picture, then we provide the super ellipsoid approximation technique. Using the technique, we can name the parts of the object. Which one is head? Which one is neck? Which one is leg and hand? Every part of the objects we can identify. We can confirm by the help of the super ellipsoid approximation. Finally, the super ellipsoid approximation we are going to convert in the graphical representation. Earlier I am showing the graphical representation 3D DFT format we convert here. The 3D DFT format only can input for the next processing steps. So the first, the medical surface segmentation, the picture is called Voronoi diagram. Here we are using the Fox strategy. The Fox strategy and Voronoi diagram only consider just of the object. We can finalize the boundary of the entire object. So this technique we are using. This is the formula for the Voronoi diagram calculation. This is the pseudo code for the entire readjustment segmentation process. Super ellipsoid. This slide earlier I discussed in the overall image. Then the shape features normal measurement functions. We are using the default shape feature measurement functions only. Already available existing functions only here we using for the calculation. The area, aspect ratio, roundness, perimeter, circularity, uniformity, mean, standard variations. These are all the formula is already available formula only we are using here. Then second feature is color. Normally the color values we can measure using many format, RGB, HSV, many format we can using. But in the RGB value, if we go for the RGB value, we can use only the primary colors, 0 to 256 only we can using by the help of RGB. We felt the RGB is not the RGB alone is not enough to identify the semantic value of the image, because some typical images, some typical colors, uh, some some unique colors, it's not available in RGB range 0 to 256 is not available. So we feel HSV we can get unlimited of colors using the HSV technique. So the entire process we are using the HSV technique to identify the color feature. The HSV also we are using the normal formulas, which one is earlier available. The same formulas we are using here, mean, variance, skewness. We use to identify the color feature. These are the formulas: mean, variance, skewness, to identify the color feature. This is RGB to HSV conversion diagram. And third feature is a texture feature. First two features we completed. The third one is texture. The texture we use direction and edges and roughness of the each and every surface of the texture. The area orientation and angle based only we can find the exact texture value. Normally we use the range of 0, 45 degree, 90 degree, 135 degree grayscale co-occurrence matrix we are using to find the texture feature. It's already available common features only. The texture features we are using the standard formulas: angular second moment, construct, entropy, correlation, mean, variance, homogeneity. And fourth one is object based feature. It means motion feature. The motion feature, in every object, in every frame, some objects keep on moving. That motion we going to identify. The motion feature is mainly four parts: motion content, motion uniformity, motion panning, motion tilting. It's the four features is used to help the to identify the particular objects, particular frames, object movements. This is one of the sample image. The first image, the moving objects and non-moving objects in available in the particular frame. The building and the street light, these kind of the object is static, they are not going to moving. The human beings and the vehicles, it's possible to moving in each and every frame. We need to tracking the consecutive shots. The first shot, shot means the frame. The first frame, some of the object is not moving. The second shot, the second frame, the particular objects starting the moving. And each and every frames we need to monitor and we need to record the objects movements. That is the that information is helped to identify the movement of the object. So this is on sample image. This image, most of the peoples is walking towards our friends. These peoples is we represent the moving object. Then after completing the two functions, the input we are going to provide the backup visual words. Backup visual words based, we are creating the clustering format. The backup in visual words, the user input already we collect the backup visual words. The corresponding and the database already we get the backup visual words. Both visual words comparison based only we choose the similarity frames and the images. Backup visual words, we collection of local and global words. In the orientation scaling based, we collect the information. The backup visual words, finally, we convert in the backup visual vocabulary. The backup visual word means the pixel value only we using this name backup visual words. Backup visual words we are using mainly using the triplet function. Triplet function tbbct we are using tbbct using to create the tree format of the clustering. The which one the which are what are the key frames, what are the key images we going to hierarchical in the IA position of the tree. That is our key element, that is our key frame. The constructor of visual vocabulary, the first we are using the TBBCT, triplet based predictive clustering tree. Using the tree, we can create a top-down approach. The top of the part, the key frames, the key images only available in the top of the tree. The down of the part, the less similarity, the next second level of the frames only in the available in the bottom of the tree. All the frames we create the we create some visual words. The visual words only we going to further similarity and the ranking process. The backup similar words sample image. The feature extracted images we provide the visual words. The visual words based k nearest neighbor algorithm is processing. Based on we get the clustering. Clustering we convert in the code book generation. Code book in the sense pixel value we can consider in the all the elements of the cluster. Finally, the backup visual words is come to the next stage. Then we get the corresponding histogram value of the backup visual words. This is backup visual words normal pseudocode. Then similarity matching. After collect the backup visual word, we collect the similarity matching by the help of a K nearest algorithm. Using this algorithm, we get the similar value frames. Yeah, n number of frames available means we get only very accurate similar matching frames only. Here, the accurate of the value we can calculate by help of L2 distance function. Which one is the which pixel is frequently occur into the all the frames. Based we select similarity matching. Here we using the L2 distance function. The finally ranking. Top k nearest neighbor we are using to identify the ranking question. Most relevant to video we can ranking by the help of this function. Then our entire process is done through the map reduce environment. Map reduce environment is mainly helpful for the tree function speed up the processing speed. Almost we are using 5 features, 5 processings, keyframe extraction, feature selection, similarity matching, ranking, backup visual merge. 5 features we are using. All the features after complete the, all 5 features, only the final output is comes to the user. So the each and every stage took some processing timing. So we using the normal system, definitely the processing time is very high to compare the map reduce. So the speed up is one of the major feature by using the map reduce. And second one is size up. The size up in the sense the storage capacity. We can store and retrieve and we can process unlimited frames and videos. So size up wise it's very helpful to the entire process. The scale up wise is absolutely very good. This is the map producing process. We can provide the large set of data set. All the data sets is cut in the keyframe function. After completing the keyframe, we go for the feature extraction. And the feature extraction 3 functions here occur: save color texture. Finally, the reducer collects the extracted features. This is one sample image, sample output representation, and the user going to provide one query input. And the query input, the one player is there. The player dress color is green color, and after the input based 3 functions, 3 features is occurring: color, shape, texture, motion. 3 features. and 3 features based. The database relevant videos only finally going to display. This is one sample image for some gaming application based on sample image. Then our experiments. Normally in Hadoop system, minimum one master and one slave need to do the process. In our system, we are using 5 slave and one master node. Totally 6 nodes we are using, one master and 5 slave. This is the configuration of the system. We mentioned the system specification. What are the things we are using in the entire process? Here we list out. So this is on testing environment. The user provide the input image in the 3D format. The corresponding entire process, the master slave, master node have the entire data collections. Based on the data collection, the all 5 slave nodes are doing the entire process, and finally they provide the result. This is our data set, and the data sets in the early after completing the literature survey, we find some data sets, some data set details frequently used in many papers, but they are not concentrating the video retrieval techniques, but the image processing 3D information 3D image processing papers, the mainly focus in 3 data sets. So here we are also using the 3 data sets, the same data sets. First one is Hollywood 3D and YouTube 8M segment and Namo 3D. These 3 data sets we using our entire process. These and all the 3 data sets we have unlimited data. We have a variant of video collections like camera motion, some texture, some in-depth images, some surveillance camera based videos, all kind of the video formats we can available in the 3 data sets. So we choosing the data sets. This is our publications. Totally we published 5 papers. One is SCI and 2 Scopus and 1 IEEE conference and 1 Springer conference. This is our comparative study. Totally, we consider 8 parameters in our comparative study. All the parameters we compare into our existing system. All the 8 parameters we get better result to compare the existing system. First one is precision. The precision in the sense sum of videos retrieval divided by relevant videos retrieval. Totally data sets have how much videos, out of them we collect relevant videos only. And the precision we call the name of the ratio based. The ratio finally we get 0.98. So this is the precision's performance metrics, and the bottom of that 500, 1000, 1500, 200, we mentioned the number of queries. All the 3 data sets. In previous slide, we display we using 3 data sets. All three data sets we consider in our 8 parameters. The first, the precision values we consider in the Hollywood 3D data set. The 500,000 number of queries here we are representing here, and left side and the precision value is available. Here the second data sets we are consider the same process precision value. Then third data set we consider the same process. Finally 3 data set based comparison result we are showing here. First, the Hollywood 3D data set, our proposed system provides 0.98 ratio. YouTube data set 0.981 and Namo 3D 0.982. The compared to the existing one, the final column we represent the existing values. Existing values 0.8, 0.87, 0.88. to compare the 8 existing values in the all three data sets, better provide them better result in our precision value. So this is our first performance study. Second one is recall. Some of relevant videos in the database. Totally, how much number of videos in the database divided by relevant videos retrieved. How we retrieved totally. The final ratio is 0.97. Here we follow the same procedure for the for based on the precision. All three data sets we are using the same recall value. The bottom we display number of queries. Left side recall values we are mentioned here. This is the Hollywood 3D data set graphical representation. This one is YouTube, and this is Namo 3D. Finally, this is comparison for the recall ratio to compare the existing and proposed. All three data set based here we provide the final result. The 0.965, 0.961, 0.962. These are the values we get the recall matrix, recall performance value, and compared to the existing all the three studies provide the very good result. Then F measure, F present, the combination of precision and recall value based we get the F measure value. The F measure value normally we consider in the ratio format. The ratio finally we get in 0.78 ratio. Here we using the same method. All three data sets we using the F prime measure. This is the final value. All three data set based we represent the final table 0.96, 0.969, 0.97. Compared to the existing study, our system is highly provide the better result. Then the fourth one is retrieval accuracy. How much quality of, how much accuracy of retrieval processing we get. The retrieval accuracy is one of the major issue in the all retrieval techniques. It either text, image, video, format, any kind of the data format. The retrieval accuracy is most important for the common retrieval process. In the retrieval process, normally we consider the percentage value. The percentage 99.5% we get the retrieval accuracy rate. Here we using the same three data sets. We using the same metrics, number of queries and accuracy percentage based. We consider the values. Finally, in our data sets, respectively, we get 99.2, 99.6, 99.6 values, and compared to the existing, our system is highly recommended. Then retrieval error rate. How much percentage of the error we going to reduce? Here we list out the information. Very minimum level of the error rate only we can receive. We felt it is biggest achievement in our system. All the three data sets again we are using for to calculate the retrieval error rate. All three data set based, here we list out the table. In our system 0.12, 0.14, 0.02. This is the error rate in all three data sets. To compare the existing data sets, existing error rate, we get the better, very minimum, very nominal error rate only we can receive. In future, we plan to avoid this kind of the error rate also. Retrieval time normally not based on the any single process. The retrieval time in the sense it cover all the process in our proposed system. For example, the beginning, feature extraction, keyframe selection, backup visual words, ranking, similarity, all the process, all 5 process based only. Finally, we get the retrieval timing. The retrieval timing in earlier study, we get a huge retrieval timing because we using the normal system. After the study only we find the Hadoop map reduce system. After get the idea of the Hadoop map reduce only, we reduce the retrieval time in very minimum, very nominal. The retrieval timing here we are measured in the sense of the millisecond format. All five process in each and every frame we need to consider all five process. After complete the all five process only we get the extract semantic image. The all five process in each and every frames single image we need to spend 195 millisecond for the all five process. So the table again we consider in the three data sets for the retrieval timing. Three data set based, finally we list out the final comparison table. In all three data sets we get 200% result to compare the existing one. That is I feel very happy to introduce system, because we achieve 200% difference between the existing and the proposed system. These achievements definitely possible through using the MapReduce system only. If we choose the normal system, definitely this kind of achievements is not possible. So the MapReduce is main help to achieve this kind of the huge difference. And find keyframe selection. Keyframe selection in after collect the videos we get number of frames. So out of the frames how many keyframes we can get it, that information here we list out. For example 1500 frames we get after convert the video. So out of the 1500 we get 364 keyframes using the Gaussian filter and smooth histogram functions. This is the graph for the keyframe selection details. The noise filtering accuracy, how much we reduce the noise level, that is we mentioned the percentage format. Here the noise level we are measuring, noise filtering accuracy, noise level of particular one data set. All the three data sets we comparing the noise level. Finally the noise level, the noise level also is huge difference to compare the existing one, because they using very few features only, the existing papers they are using, but herely ultimately we using all major features, so we can achieve this level. Positive result, the out of the database number of videos is there. Out of them how much positive result we can get it, here we showing the name of positive results in the percentage value 99.8%. Again three video data sets we comparing the positive result. Positive result rate also we can provide the better, we can get the better result to compare the existing one. Conclusion, the majorly there are more four major issues in the retrieval processing. The relevance, how relevant data we get in the corresponding output, and the processing timing, and the noise level and duplicates. These four important retrieval techniques issues definitely we solving here. By the help of the multi-feature extraction technique. Here we are using the four different feature extraction techniques. Using the four techniques, we can get the better result. And MapReduce also get the better processing timing and storage capacity. The fast and higher capacity result we achieve 90.75%. Retrieval accuracy rate 0.01. We feel to compare the existing systems, it is very minimum and very less number of figure only 0.014. And high noise filtering accuracy, we remove most of the noise level. high correctness and completeness of frames only we can get it. Future direction. Based on the study, we find some issues try to solve in future. The first in near duplicate video detection. In our system, only identify the exact value. The exact value based input and output matching means our system recommend to show the corresponding output. But in future we try to list out some related nearby value also we need to list out in future. And second one is spark. After study the normal system, after what the normal system, we find Hadoop MapReduce is better for the processing timing and storage capacity. But after completing the Hadoop system, we felt we attend some conference. The conference based we learn and some papers based we learn. Apache Spark is more faster to compare the Hadoop MapReduce system. So in future we try to do the entire process in the Apache Spark environment in future. Then third issue is traffic. We need to reduce the traffic ratio. On the particular timing, many number of the users want to access the system. For example, the Google itself we need to consider. And the Google, the worldwide, the particular fraction of second, how much of the request is there. So all kind of the requests, the system definitely need to support. We never restrict the users. We never restrict the user queries. We need to allow unlimited of the users in the particular second moment of the timing. So we introducing the scheduler concept. Using the scheduler, we can manage unlimited of the customers, unlimited of the users, unlimited of the traffic. We can allow. In future, we plan to do the process. And then fourth one is video streaming. The live streaming, for example, some cricket match is going, some any live conference is going. Based on the live streaming video based, we want to retrieve the same concept, image to video retrieval. We want to do the same process in the live streaming video based, and the surveillance camera based we want to do the same process. These are the main focus in our future work. And list of publication, totally 5 papers we published, and references. Thank you, ma'am.
Now it is hello, is it audible?
Yes, ma'am.
Yes. Now it is the query section. I request the participants raise your queries if you have any doubts in his presentation. Participants, are you have any doubts in his presentation? Anybody? Shall I take my turn? Now, Ranjit Kumar,
Yes,
tell
ma'am.
me,
Anjali?
that is, how your work is going to help to the society. That is, our MHRD or UGC or the central government, what they are suggesting is any research that the students, the scholars, as they are doing, how it is going to help to the society. Now, tell me about this one.
Yes, ma'am. In our system is we frame to use the normal peoples, because not only the research scholars, not only the university members, all of them today we need to find the solution using the search engine and social networks. The retrieval system is mainly recommended for the social
Do some
network.
application.
Yes, Google search engine is
Just give
one
some
of the.
applications.
Yes, ma'am. Google search engine is one of the major application, ma'am. the retrieval process is mainly possible in the Google search engine. So in recent days, any people's using the Google search engine for the any needs, they are referring the Google search engine. In the Google search engine right now, there are text retrieval, text to image retrieval, and text to video retrieval option is possible. In future, the Google search engine also they using the same system, image to video retrieval. It is in future it possible to using the Google search engine also, ma'am. Google search engine and any of the social network is possible to using the same concept for the
Ranjit,
retrieve. Yes, sir.
in Google, you don't have the possibility to search the images?
Sir, text to image is possible.
Hmm.
Image to image is possible, but our concept image to video retrieval. So right now we want to retrieve the videos in the search engine or social networks. Definitely we need the help of the data format in text or image. Text we need to
But
provide. But
okay, but when I am giving something to be typed in Google search,
okay, sir.
it is giving an option all will be the first tab,
Okay, sir.
image will be the second tab,
Yes, sir.
video will be the third tab.
Yes,
Then
sir.
even I can search a coin and then I
Okay,
will
sir.
get the relevant information about the coin. Then
Okay,
I
sir.
will get the images and I will get the relevant video. How
Okay,
can
sir.
we say that facility is not available?
Yes, sir. You also say that you going to type. The type means you going to the provide the data format in text format. But in our study is we provide the data format in image format. So
Even I
user
can
will.
give an input for my Google.
Sorry, sir.
I can give image.
Ranjit,
Yes, ma'am.
Ranjit, that is
Yes,
you,
ma'am.
you submitted your thesis in the December 2018. That is 1.5 year is over.
Yes, ma'am.
Okay. During this period, okay, had you gone through, that is Satish Kumar sir is telling that, is there any advancements related to your work in this period, this 1.5 year? Because one of the examiner is asking that what you are doing, okay, that is the future directions as you are giving in
Yes,
your
ma'am.
work. Okay.
Yes, ma'am.
Related to that is are you doing or at the same time any research scholars are they are doing this type of the works? Satish Kumar sir is telling that if you give just the coin image, okay, it has to find out that image in the videos. That type of the work had you seen at present days in the Google? Had you observed?
Yes, ma'am. We also find some papers related to that, but the system is taking huge processing timing, and the noise level and accuracy rate is very low,
Ranjit,
ma'am. I am also.
Ranjit,
Yes, sir.
if you feel that this facility is not available on Google, have you approached Google
Yes, sir. Definitely,
for
sir.
deploying your have you approached? My question is, have you approached?
No, sir. Not that
Approach
we
meaning,
approached, sir. Not that we approached, sir. We work the entire environment in some limited resource based only. We search the we try the solution. We check the entire process.
okay.
And future we plan to do the same process in huge volume of data sets and very high capacity of the storage sector based. We need to check
How
the
you
system
have
after
how you have tested, Ranjit? You have developed some model
yes, sir.
and then you have tested with limited availability. What can you tell me that limited availability?
Yes, sir. In our system, we using the one master node. In the one master node, Hadoop MapReduce master node, and the 5 slave nodes we are using. The 5
Mhm.
slave nodes in the Hadoop, we create 5 different slave nodes and
Mm.
one master nodes we designing. Out of the 6 node based, we do the entire processor.
Now, how you tested, he is asking. That is, you took that some 100, 200, 500 images from the data set that is available. No, with that one you are testing, isn't it?
Yes, ma'am. Already we mentioned. Yes, ma'am. Already we mentioned 3 data set, ma'am. The 3 data set, there are n number of the videos available. Out of the limited database, already we checked the entire process.
How many videos are available?
So nearly 800 to 1,500 videos available in each and every data set. We consider 3 data sets.
Is it benchmarking data set?
Yes, sir. All 3 data sets we are collecting who the researchers earlier using the previous benchmark high reputed journals. Those papers, journals based only we collect 3 data sets.
So you made your data set or the data set which is available like UCL repository or some other repository?
That is synthetic
No.
data sets, sir, that are available one.
Yes, yes, sir.
It is
It's
already
available one, sir.
In the real time data also, as we can test once if it is reach to the accuracy on the synthetic data, then we can go for the real time data sets.
The candidate is telling that he has collected the videos based on review papers.
No, sir. He
No, no,
used the data sets. Already some number of videos that are available on the data sets. That's what
Ranjit, my final question to you.
Yes, sir.
You have started from search engine.
Yes, sir.
Then you linked with the image processing.
Yes,
Then
sir.
you linked with video processing.
Yes, sir.
You linked with extraction,
Yes, sir.
information extraction,
Yes, sir.
information retrieval.
Yes, sir.
For that, you have used features.
Yes, sir.
You have used map reduced method.
Yes, sir.
Thus, you are claiming that your accuracy is good.
Yes,
Good.
sir.
My layman question to you.
Okay, sir.
Shape features are already available.
Yes, sir.
Map reduce method is available.
Yes, sir.
What is your contribution as a PhD scholar?
Okay, sir. Earlier, all the available processing only here using, sir. But the earlier papers, they using any few of the features only they consider. Either they consider object-based feature extraction techniques, otherwise content-based feature extraction techniques they are considering. But in our case, all 4 major features we are considering, so that we can improve the accurate rate and we can reduce the noise rate.
Ranjit, do you know one thing?
Yes, sir.
When I'm getting my sensitivity, specificity, accuracy, all my statistical inferences,
Okay, sir.
those inferences depends on 2 things. If
Okay.
my development in image processing or video processing or even information retrieval, which are based on some features, 2 things. My result will get vary with respect to number of features.
Okay, sir.
My result will vary with respect to hybridization of methods.
Okay, sir.
This is the 2 basic thing which each scholar has to understand.
Okay, sir.
What is the understanding line by the scholar should be here is when I'm using n number of features, I'm getting good result. I cannot immediately claim that my algorithm is fine. What is the hidden thumb rule over there? I have to use minimum number of feature to get optimum accuracy. This is the one point. The second point, one scholar will do that, he might have apply one algorithm. Second scholar, second algorithm. Third scholar, 1 plus 2 algorithm, hybridization. Fourth scholar, 1 plus 2 plus 3 algorithm. He will claim my accuracy is 98.9. And fifth scholar, 99.9. I have used these many combination. Fine. But what is the point which we have to notice there is when I'm using a number of feature or when I'm using a number of algorithm to be coupled together, what is the time? I cannot use it for real time. When the system is taking much time to take algorithm 1, algorithm 2, algorithm 3, or features, number of features, it will take much time. What I'm telling is, keeping those things in your mind, I should have the strong point, sir. 4 features I'm claiming here. These 4 features, all the existing papers have not used. Fine. Why they haven't used that few features? What is the problem? Why those authors are not considering all 4 features? That is the way you have to think.
Yes, sir.
Then why I'm taking it? When I'm taking the 4 features, then am I able to produce my accuracy in time? That is most important. When I'm going to apply this for Google, and then I'm pressing one letter, immediately it is indexing whatever the relevant words or sentence. That will immediately pop down that much faster. And then I'm taking all my features, all my algorithm, then the Google is taking much time after typing something. What you will do? You will throw your computer, correct?
Yes, sir.
So that you have to keep it in your mind. Then using the number of features doesn't matter.
Okay.
You have to use the proper number of features. Note my point,
Yes, sir.
proper number of features.
Okay, sir.
Then you should also get efficient time
Okay,
to
sir.
retrieve it. So these two things are proportionally, it will flow.
Okay, sir.
Both has to grow. You got it. When I'm
Yes,
using number of features are high, the time is also increasing. No meaning.
Yes, sir.
It should be, you know, it should have the reverse way of association.
Okay, sir.
Got it. That you check it up, you can see that.
Okay, sir.
In
Ma'am,
2018, okay.
Yes, ma'am.
That is in 2018, the work what you took and HDFS technologies as you used.
Yes,
But
ma'am.
recently you are observing that Spark is came up, isn't
Yes,
it?
ma'am. Yes, ma'am.
Okay. By using the Spark, that is you can even you can improve the accuracy and at the same time the time to access the query that you write on the videos to access the required information from the videos. Okay, it will be still reduced by using the Spark. Okay,
Yes, ma'am.
related to this, have you done any further research in this 1.5 year period? That to live stream videos, and that one also, that is real-time data. SAT is asking that the synthetic data that what you took, and at the same time, are you applied all this onto the real-time data? In these 1.5 year, just I am asking because it took 1.5 year to get the PhD degrees. Okay, we are pretty on the research scholars. Okay, but at the same time, are you continuing your research or not? That's what. In this time, had you published any articles in the IEEE journal related to your future work?
No, ma'am.
At that time itself, in the 2018 itself, suppose if you took the patent regarding to your work, okay, surely it will be published at the 2018, okay. But you have not took the patent. Anyway, leave it off. Now the Google is doing everything, the recent test, whatever as we want. But the new thing that I observed is just if you put a query as in the form of an image, it is retrieving. Query means here it is query is image,
Yes,
isn't
ma'am.
it? That
Yes,
you are
ma'am.
submitting image. One more doubt, all in your thesis you are speaking about 3D image, 3D image.
Yes,
Okay.
ma'am.
Now here my meaning of 3D means 3D image as you are telling.
Yes, ma'am.
3D image. Okay, what is the meaning of here 3D image? Because you
Three-dimensional.
are three-dimensional
Yes, ma'am. X, Y, Z.
that is
XYZ.
from image, right?
Sir?
I think multidimensional again, he is using the words in different way.
Yeah. Okay.
Madam
Right.
Ranjit, have you noticed what madam is asking?
Yes, sir. Yes, sir.
In all his thesis work, he has written about 3D image. But actually, the videos that are there, you are supplying the input as a image, okay, image as an input, and it checks that image wherever there in that videos, and it retrieves that video. This is the final work that it takes from your work, okay, which is actually appreciable. And I will raise some of the doubts that are raised by the other examiner.
Yes,
Okay.
ma'am.
What are the challenges? Okay. What aspect of the problem inspired the scholar to choose the domain for the PhD thesis? What aspect inspired the scholar to choose the domain for the PhD thesis? This is the question raised by the examiner. I have to ask in this query section. Okay. What
Yes, ma'am.
aspect? Why you are choosing this problem?
Yes, ma'am. As a layman, before start the research work, I am trying to get the image-based video retrieval process in any social network or any search engine concept, but I am not getting the proper result. So that is the first stage. I think that kind of the research based we can move to the entire research work in our figurative work. That is the initial movement, ma'am.
Okay, ma'am. Next, what are the challenges occur when a researcher performs readjustment of segmentation?
Man, the readjustment based, ma'am, the readjustment based only we can get the particular frames and particular images, exact 3D DFT videos, 3D DFT value. The value based only we can provide the further process. That is one of the geometrical feature. The geometrical we introducing the TBBST algorithm. Using the TBBST, threshold based predictive clustering tree, the algorithm using to define the clustering format. After collecting the better images, better frames, our key frames, we convert in the key tree based. That is the thing helps to increasing the better result.
A personal question.
Yes, ma'am.
What is the meaning of noise in the video? Noise in the video. You are
I
raising noise at all.
Yes, ma'am. Nice in the sense, if we cut into the video in number of frames, some frames is shaking, some gray levels is low or high, some poor quality we can get it, ma'am. So that kind of the nice image based we can't do the further process. So we need to eliminate those kind of the frames. That is nice image, ma'am.
Now, my request to the candidate, see, in your further research, or if you are guiding to any of the scholars, okay, suppose if you feel that that is the work not yet has been done, just to take the patent for that one. Nowadays, as we are not observing the scholars, they are not coming forward to take the patents. Okay, ma'am? Please be follow, because this work is appreciable at the time of 2018. Okay, and at the same time, you are telling that the spark is came up. That is, you can speed up your execution and everything by using the Spark instead of HDFS technologies. Anyway, finally, from the adjudicator or the chairperson of this committee, okay, with the permission of Satish Kumar sir, shall we announce doctor to him, that is PhD in computer science, with the permission of the Satish Kumar sir. Okay, shall we announce doctor in the computer department of computer science or in the field of computer science? Tell me about your opinion.
Ranjit, so you don't stop your research here and then you have to do much. And then I expected that you have the essay paper, your guide took a lot of strain for you, and then she was continuously asking me, sir, please come for that demo presentation, and then you have to come like that. Madam called me several times. I was not able to even pick due to my assignments. But you have to think about such kind of cares and affections which your supervisor is carrying. Why I'm telling this, yeah, you should not stop your research here. You have to continue your research along with your supervisor. That is most important.
Thank you. Yes, sir. Sure.
And I'm expecting you that the publication, when I heard that the publication is in SCA, really I had a very good expectation. And then I expected that, sir, this is my strong novel method, sir, which I have introduced like that. But anyway, it is fine. Your research is good. And then my hearty congratulations to you as well as your supervisor.
I must say thanks to Subuna.
Thank you.
And some of the participants like Danambal and some more, okay, that are presented here. Okay, I am already known about all these people, and I am not new to this Bharatiyar University. Anyway, this is the first time as I am coming into online to this Bharatiyar University. Subuna, this is the first research PhD under your guidance?
No, ma'am. He is the second man. One is under MK University.
Okay, okay. Congratulations to you,
Thank you, ma'am.
because one more into your account.
Yes, ma'am.
Okay. And I'm thankful to the Bharatiyar University providing this opportunity to me and in the presence of Satish Kumar sir.
Yeah,
Okay,
thank you,
one
madam.
and all. And we are announcing that doctorate degree to this Ranjit Kumar. And from here onwards, Ranjit Kumar is Dr. Ranjit Kumar. Okay, congratulations,
Thank you,
Ranjit
ma'am.
Kumar. Okay.
Thank you, ma'am. Thank you, Satish Kumar sir. Thank you so
Thanks.
much for your valuable presence. We will take, we will consider your opinions. Definitely, sir.
Sure.
We missed that particular pattern work. Really, we felt bad. We had so many valid suggestions. Thank you. Thank you so much. So kind of you,
Yeah.
both of you. Thank you, sir. Thank you so much.
Ranjit, it is your turn. Thank everybody.
Thank you, sir. Thank you, sir.